Kubernetes has ultimately changed the way we deal with software. It allows us to run distributed systems at scale, and it solves the challenges of running many web applications on many web servers. Making sure all servers are up and running, making sure all applications are up and running, automatically restart apps when they become unstable, move applications to healthy servers when servers go down, manages load balancers, DNS, endpoints to web applications transparently. All of this without writing a ton of scripts. Instead of writing a ton of scripts, we describe everything we want as YAML files, and many may find this interesting, but Kubernetes was never really meant to be a system for the masses to consume directly. Now, although many of us interact with Kubernetes directly, we actually end up building our own platforms on top of Kubernetes, whether this is microservice architectures, data pipelines, machine learning, or serverless platforms. Kubernetes was always meant to be a platform for building platforms. Back in my day, we had servers. We installed applications onto servers. Dealing with physical servers was limiting, so we invented virtual servers so we can abstract and better utilize physical servers. Then we got tired of maintaining physical servers, and the cloud was born. The cloud gives us virtual servers without the burden of maintaining physical servers. The cloud also gives us load balancers, networks, and more. Then we got tired of managing virtual servers, applications, load balancers, and networks, and Kubernetes was born. Kubernetes sits on top of everything. We tell Kubernetes what we want using YAML files. It will ensure applications, load balancers, firewalls, and all these things are constantly up and running and healthy. Now, for small companies to be productive, learning Kubernetes can arguably become a burden. And for larger enterprise companies, managing Kubernetes at scale with distributed large teams can also become difficult. Now, for many people, this may sound a little bit strange, but what if we could make Kubernetes disappear? No YAML files, no Docker files. What if there was a way? Shipper is a modern platform that sits on top of Kubernetes, focused on developer and operations productivity. As a developer, we write code, we tell Shipper where our code is, Shipper takes it, containerize it, deploys it to a Shipper node. A Shipper node can run on any cloud, AKS, EKS, GKE, and more, giving us multi-cluster, multi-cloud capabilities. Today's video is sponsored by Shipper. Shipper is a very interesting project with very high ambitions. When I saw what Shipper was designed to do, I was super keen to find out more. And today we're going to take it for a spin. So if you take a look at my GitHub repo, in the Kubernetes folder, I have a Shipper folder, and in here I have a README. This README will be showing you all the steps, source code, and documentation that we'll be following today. So be sure to check out the link to the source code down below so you can follow along. So to get started, the first thing we're going to need is a Kubernetes cluster. Now, to create a Kubernetes cluster, I'd like to use a utility called Minikube, which allows me to deploy a Kubernetes cluster on a hypervisor such as Hyper-V or VirtualBox. So to create a Kubernetes cluster on Minikube, I'm going to say Minikube start, and I'm going to run Kubernetes 1.18.2. I'm going to give the virtual machine 5 GB of memory, 20 GB of disk, and I'm going to use the Hyper-V driver. So I copy this command and I open an administrative PowerShell window and I run this. This will give me a one node Kubernetes cluster on Minikube that I can use for testing. And that command will go ahead and create a Kubernetes cluster on Minikube. And to make sure it's working, I can say kubectl get nodes and we can see Minikube is up and running, ready to go. Now, when we deploy Shipper, we're going to need two endpoints. One endpoint is for the Shipper API and the other is for deploying and exposing our applications. Now, because Minikube doesn't have a load balancer, I'm going to route two static IPs to my Minikube cluster. If you're deploying this to the cloud, we'll get a load balancer provisioned. So to add the two routes to Minikube, I'm going to create one route for the Shipper API. So I say route add, and I'm going to expose 10.100.10.10 for the Shipper API. And then I'm also going to say route add, and I'm going to expose 10.100.10.20 for our applications. And I'm going to route this to the Minikube IP address. So I firstly go ahead and create the route for the Shipper API, and then I create the route for our applications. If you head over to learn.shipper.io, they also have an official document on how to install Shipper on Minikube, so be sure to check that out as well. So firstly, let's talk about everything we need to get started. So I'm going to change directory to the Kubernetes Shipper folder. And once I'm in that folder, I'm going to go ahead and create an installs directory where we're going to download all the stuff we need to get going. So I go ahead and do that, and we can see we now have an installs directory that's empty. So to interact with Kubernetes, we obviously need kubectl. So if you haven't got kubectl, you can go ahead and run curl and download the kubectl exe. To install Shipper, we're going to use the official Shipper Helm chart. So we're going to need the Helm command line as well. To install the Helm command line, I'm going to say curl, and I'm going to run curl on the gethelm.sh endpoint, and I'm going to download the zip file that I need with Helm 3.4.1. I'm then going to unzip that, and I'm going to move helm.exe to the installs folder, and I'm going to remove the zip file. So I go ahead and run that. That'll download the Helm exe to my local folder. So next up, we're going to need the Shipper CLI, and to get that, I'm going to run curl, and I'm going to grab v1.1 of Shipper for Windows. So I go ahead and run that. That'll download the Shipper CLI to my local folder, and once that's done, all I'm going to do is rename it from Shipper Windows AMD 64 to shipper.exe. So I go ahead and do that, and now if we take a look at our installs directory, we have all the dependencies we need. We have Helm, kubectl, and Shipper. So now I can go ahead and take these files and move it to my path so I can run it on the terminal. So I should be able to say kubectl get nodes, and we have our Minikube cluster up and running. I should also be able to say Helm, and we can see the Helm is installed as well, and I can say Shipper, and we can see that CLI is installed as well, ready to go. So now that we have a Kubernetes cluster and we have the Shipper CLI, in order to install Shipper, we need the official Helm chart. Now, if we head over to the official docs, there's an installation guide for Shipper with directions on how to install the Helm chart. And if I head over to this GitHub repo, we can see that they have a Helm chart GitHub repo with documentations and installation instructions. We can also see there's a releases section with the release 1.1.1. And if I go in there, we can also download the zip or the tar file directly from here. So to download the Shipper Helm chart, all I'm going to do is say curl, and I'm going to download it straight off GitHub. And I'm also going to download the version 1.1.1. I'm then going to go ahead and unzip it, and I'm going to rename it from Helm chart 1.1.1 to Shipper-Helm chart 1.1.1 so that it makes sense. So I go ahead and run that, and that'll download and extract the Helm chart. We can see in our installs directory here, we have our exes as well as the Helm chart directory right here. So to start the installation process, the first thing I'm going to do is change directory to the Kubernetes Shipper installs folder, and I'm going to change directory to that Helm chart directory. I go ahead and run that, change the directory, and we can see in this Helm chart we have a limits.yaml. The limits.yaml will allow us to provide a CPU limit on the namespace where we want to install Shipper. Since I'm going to be deploying it to the default namespace, we'll go ahead and say kubectl apply, and we'll apply those limits to the default namespace. So I go ahead and run that, and the limits would be applied. The next thing I'm going to need to do is say helm dep up so that I can go ahead and download the Helm chart dependencies for the Shipper Helm chart. So I go ahead and run that, and that'll go ahead and download the dependencies. We can go ahead and see inside the Helm chart there's a charts folder, and the dependencies are being downloaded into there. So to install Shipper, it's really simple. I say helm install Shipper dot, because we're in the folder of the Helm chart. I specify a timeout of 15 minutes. I set our metrics image. I also set the default administrator username and password, and because I don't have load balancer capabilities, I'm going to set the Shipper API to be a service of cluster IP, and I'm going to give it an IP address for those routes I exposed. So that's for the Shipper API. Now to access our applications, Shipper internally runs an Nginx ingress controller. So to access our applications, I'm going to set that service type to cluster IP, and I'm going to also set the cluster IP to the 10.100.10.0. Those are the two IP addresses I added routes for in Minikube. In a couple of minutes, we'll take a look at how to deploy this to the cloud and use a real load balancer. So to deploy this, I'm going to copy all of this and I'm going to paste it to the terminal. That'll go ahead and deploy Shipper Helm chart to our cluster, and it'll take several minutes to get up and running. So after a couple minutes, we can see everything is now up and running. So firstly, you'll see the Shipper core components start up. A couple of minutes later, you'll see these node containers, and then a couple of minutes later, you'll see the dashboard. That is how you know Shipper is good to go and up and running. Now let's take a moment and forget about Kubernetes. The goal of Shipper here is to make Kubernetes disappear. Now that Shipper is up and running, let's point the Shipper CLI to it. Now to do that, Shipper has the concept of targets. So we can say Shipper target list, and we can see we have no targets listed currently. And what I need to do is add a target and give the target a name. So I can say Shipper target add, and I can call it dev, and I can point it to the IP address of where the Shipper API is running. This could be a load balancer IP, or in this case, the Minikube IP address for that route. So I go ahead and run that. We can see now we have a new target called dev pointing to our Shipper API. I can say Shipper target list again, and we should be able to see it. And let's go ahead and set a default target by saying Shipper target set dev. And if I do Shipper target list again, we should see we have a little asterisk next to it. So that is our default target now. So you can have multiple Shipper targets, one for local and maybe one for dev and production. Now the next thing we have to do is log into Shipper. Shipper has rich security features built around users and teams. So we can have users belonging to multiple teams. So to log in, I'm going to say Shipper login, and I'm going to pass in the admin email with the admin password that I used to bootstrap Shipper. And we can see now we successfully logged in. Now to see our infrastructure, we can say Shipper cluster list, and we can see we have one cluster listed here called Shipper core. Its provisioner is Kubernetes, that's its address. And the cool thing here is we can see that we have one pool in this cluster. So Shipper has this concept of pools, and we can say Shipper pool list to view all the pools. And we can see Shipper comes pre-shipped with a pool called the one pool, which is the default one for our cluster. Now a pool is a landing pad for applications. It gives us the flexibility to apply configurations to applications running on different pools. We can have a dev pool, a staging pool, or a production pool. We can have an Azure pool, an Amazon pool, or a Google pool. We can also have pools per team or departments. Pools basically give us this flexibility. If we take a look at the Shipper docs, we can see that it allows us to deploy many pools per cluster. So we can have application 1 and 2 running in a namespace on Kubernetes, which is deployed to a single pool called pool A. We can then deploy separate apps in a different namespace and deploy that on pool B. Similarly, we can have multiple apps running on pool C, and these all run on the same cluster. We can also introduce a fourth pool called pool D and potentially run that on a different cloud provider, as long as one pool does not point to multiple cloud provider, because this does not make sense. Now to show you how to add a pool, you can say Shipper pool add, the name of the pool, and we can expose a pool publicly to allow all teams to consume it. We can also define a Kubernetes namespace for that pool, and that can be assigned to, let's say, our dev team, and then we provide a provisioner for Kubernetes. Shipper is capable of having multiple provisioners under the hood, but currently Kubernetes is the main provisioner. So I go ahead and run that, and that'll create a new pool. I can then say Shipper pool list, and we can see our pools, including our new pool that we've just created. Now the next bit for us is to create a team for our developers. Now as an ops person, we may want to set up different teams for different developer groups or departments. We can then set up security around each of these teams. Those team members can then take part in deploying apps to development or production. So to add a team, I can say Shipper team create and the name of the team. So I can create one team called dev team, and if we run that, that'll go ahead and register a team. The next bit here is to give our team access to different pools. So for that, I can say Shipper pool constraint set, the name of the pool and the name of the team. So I go ahead and run that, and that'll give the dev team capability to access the default pool, which is called the one pool. So now that our ops team have installed and prepared Shipper, let's put our developer hat on and see what it takes to be a developer to code and deploy applications to Shipper.
If I'm existing in this plane, why don't I vibe with anybody? No.
So now I'm a developer and I have some code and a terminal. So the first thing I'm going to do is switch directory to where my code is located. I say cd to the Kubernetes Shipper developers Docker folder, and I have a Golang application. So I'm going to change directory to that. And in this folder, you can see if I do ls, I have a Docker file and a Go application. This is a small Golang application that imports some dependencies like a web server and then starts up a web server on a given port. And then every time that web server gets accessed, it says hello world from Go. Golang on Shipper. I also have a Docker file. Since we like to use Docker, we can say from Golang. We can create a directory called app, set it as working directory, copy our code into that, say go build, and set the entry point. So a very simple Golang application running on Docker. So to build my application, I'm going to say docker build dot, and I'm going to tag my application. That'll go ahead and build up a container image. I can then say docker push, and I can push that to a container registry. Once I've built and pushed my Docker image, I can create my application in Shipper by saying Shipper app create. I can give it a name like go hello world, and the type of application, which is static, which refers to Docker containers. I can then specify the team I'm part of and the pool I want to deploy to. And when I do that, we can see that Shipper has gone ahead and registered our application, also given us a Git repository where we can push code to. Now to deploy the application, all I need to do is Shipper app deploy, pass in the name of the container image to deploy, and the app I want to deploy it to. So I go ahead and run this, and this will do all the magic for me. This will go ahead and deploy my application to a Kubernetes cluster, set up all the stuff like services and deployments and pods, wire it up for traffic behind an ingress controller, and do all the magic so that I don't have to without any YAML files. So we can see it's gone ahead and deployed, it's created a deployment, rolled out a pod, deployed our container image, set up all the routing, and it's done with no YAML file needed. Simply say docker build, docker push, Shipper app create, Shipper app deploy. Now before we take a look at our application, let's see if we can deploy another language such as a Python container. So for that, I have a folder called Python. In here I have a server.py, which is a Flask application running a Python application web server that returns hello world. I have my requirements txt saying I want Flask. I have an entry point stating how to run Flask, and a Docker file where I say which Python I want to use. I copy in all my requirements. I say pip install. I tell Flask where my server is, and I start up my entry point, and I expose it on port 5000. So as a Python developer, I have a terminal. I change directory to my Python folder. I build up my container image saying docker build -t, and I tag it. That'll build up my Python container. Then to push that to a registry, I say docker push. That'll push it to a registry. And then I need to tell Shipper about my application. So I say Shipper app create. I'm going to call it Python hello world. I again say static because it refers to a container image, the team I'm part of, and the pool I want to deploy to. So I go ahead and register that application, and it also creates a Git repo for me. Shipper also allows me to register environment variables for applications. So I can say Shipper env set, and I can set an environment variable. In this example, I'm going to say Flask app, and I'm going to point it to my server.py for the application Python hello world. So I can create an environment variable as well. And then to deploy my app, I just say Shipper app deploy, point it to the Docker image and the application I want to deploy that image to. I go ahead and do that, and Shipper will do all the magic for me. It'll create a deployment, roll out the containers to a pod, set up the routing, and deploy it behind an ingress controller. It'll do all of that magic without a YAML file. So you can see we've entirely gotten rid of Kubernetes and all the YAML. If you want to get rid of the Docker file, Shipper allows you to do that as well. If you go to the Shipper documentation, there's an example on how to deploy multiple different types of programming languages without a Docker file. We simply use this mechanism called a proc file to tell Shipper about our process and how to start it up. Shipper will then figure out all the magic, build up a container image, create a deployment in Kubernetes with a pod, and set up the routing and add it behind an ingress controller as well. So we've taken a look at Docker image application, but there's also examples on Node.js, Ruby, PHP, Java, Golang, and Python without any need for a Docker file. And now we can see our Python application has been deployed to Shipper. Now to see both of my applications, I can say Shipper app list, and we can see our Go Hello World as well as our Python Hello World has been deployed and exposed on an ingress controller over here. So as a developer, I can immediately take this URL and I can open it up in the browser, and we can see if I do that, I now have my Go Hello World running in Kubernetes behind an ingress controller without any YAML. I also go over to my Python one, and I can see I've got that application running as well. So this demonstrates the concept of Kubernetes disappearing below the stack, almost like an operating system kernel. Developers don't have to interact directly with Kubernetes at all. So instead, development and operations simply interact with the Shipper API, which hides and abstracts away all the complexities of dealing with Kubernetes. Now, just like accessing any other app, the Shipper dashboard is also deployed as a Shipper application. I can take this URL and open it in the browser to access our dashboard. And when I do that, I can access the Shipper dashboard and I can go ahead and log in. And this will give us an overview of everything we've deployed to Shipper. We have a users panel where we can add and remove users. We can manage teams. There are events, so you can see events of what's happening on the platform. We have clusters, so you can see we have one cluster up and running over here. We also have pools, so you can go ahead and manage pools. And we can see if we go to applications, we can see our applications that have been deployed as well. And the dashboard gives us a nice overview of everything deployed to Shipper, as well as the geographic app distribution of all the clusters running behind Shipper platform, as well as our nodes distribution, so we can see multiple nodes for different cloud providers. We also have pools, applications, and number of nodes we've deployed. Now, what got me really excited is this multi-cloud view that we have over here. You can see we can run multiple Shipper nodes across multiple cloud providers. We have Google, Amazon, Azure, Oracle, and more. So let's dive in a little bit deeper and put on our ops hat. So now I go ahead and put on my ops hat and I have a Kubernetes cluster running in the cloud. If you need a Kubernetes cluster in the cloud, please check out my Kubernetes in the cloud playlist, which I'll link down below, and that'll help you get a cluster on Azure, Amazon, Google, DigitalOcean, and Linode. Now you can see here below I have a Kubernetes cluster running on AKS. So I'm going to go ahead and use that as my dev environment, and I'm going to install Shipper to AKS. So I change directory to Kubernetes/Shipper, and I want to install the Helm chart. So in this scenario, I'm going to show you how to install Shipper on a cloud cluster like AKS, and then for multi-cloud we can use AKS for our development and Amazon for production. So before I install Shipper, the first thing I'm going to need to do is set my username and password for my administration account. So I'm going to say cat. In the ops folder, I'm going to create a values.override.yaml, and I'm going to set the admin user to my username that I want to set for the admin and the password. So I go ahead and run that. That'll create me in the ops folder here, values override with my username and password. Next up, we're going to need a namespace. So what I'm going to do is I'm going to say kubectl create namespace, and I'm going to deploy everything to the Shipper system namespace. I go ahead and run that. That'll create a namespace where we can keep everything isolated. Now, the same as Minikube, I'm also going to apply the limits for the CPU limits on the Shipper namespace. So to do that, I'm going to say kubectl apply in the Shipper system namespace, and I'm going to apply the limits from that Helm chart. That'll go ahead and create limits for CPU on that namespace. Next is the Helm install. I'm going to say Helm install Shipper, and I'm going to point to that folder where the Helm chart is. I'm going to give it a timeout. I'm going to give it a namespace to deploy to, so Shipper system, and I'm going to give it my values override file with my username and password for the admin account. I go ahead and copy paste this to the terminal, and that will go ahead and deploy Shipper to our AKS Kubernetes cluster. Now, the same as Minikube, we can do kubectl in the Shipper system namespace. This time I can say get pods. We can see all the Shipper core components are coming up, so we have to wait for the core components, the 2 node containers, and the dashboard before we can proceed. This will take a couple of minutes, and after a couple of minutes we can now do kubectl in the Shipper system namespace get pods. We can see all the core components are up and running, the node containers are up, and the dashboard is up, so we're good to go. So unlike Minikube, when we run Shipper in the cloud, we'll actually get a real load balancer provision. So if I say kubectl in the Shipper system namespace get service, we can see the Shipper ingress has been provisioned with a load balancer external IP address. I can then grab a hold of that IP and add Shipper as our target. So currently you can see I have no targets available. I can go ahead and add that AKS target by saying Shipper target add dev AKS and the IP address. That's gone ahead and registered that target. I can then set that target as my default, saying Shipper target set dev AKS. That'll make it the default. If I now list it again, we can see it has the asterisk sign and it's the default target. So let's go ahead and log into that Shipper target by saying Shipper login and the username. We can then look at our values file to grab the password, and we can successfully log into Shipper. We can then look at our Shipper node by saying Shipper node list, and we can see we have a Shipper core cluster running on this AKS node. We can also see the applications by saying Shipper app list, and we can see the dashboard is also deployed as an application application here. Now, since I don't have a DNS for that, we can simply add this IP address and DNS to our host file. Before I access the dashboard, the next thing I want to do is create a team so my development team can deploy to Shipper. So for that, I say Shipper team create dev team. That'll go ahead and create the dev team in Shipper. And I also want to add a pool constraint to allow the dev team to deploy to the default pool. So I say Shipper pool constraint set the one pool to the dev team, and I append it. So I go ahead and run that, and now the dev team will be able to deploy to this pool on AKS. So now that we have a Shipper pool running on a Shipper node on AKS, and we've set up a team to be able to deploy to that, let's set up a multi-cloud environment by adding an Amazon Shipper node that's running on Amazon EKS. So as the ops guy, I can go ahead and provision an EKS cluster on Amazon. We can say kubectl get nodes, and we have a one node Kubernetes cluster running in Amazon on EKS. So first thing I'm going to do on my EKS cluster is I'm going to change directory to Kubernetes Shipper folder, and in order for Shipper to connect to EKS, what we need to do is deploy a service account with RBAC roles to our EKS cluster. This will create a Shipper admin user, create a cluster role and a cluster role binding, and allow our Shipper component in AKS to talk to Amazon. So if we take a look in our Shipper directory, we have an ops directory with a Shipper admin service account, and here we define a service account with a cluster role and role binding. So to deploy that, I'm going to say kubectl apply, and I'm going to apply that YAML file to my EKS cluster. Now to add a pool to allow developers to deploy to EKS, I'm going to create a new Shipper pool. I'm going to say Shipper pool add, and I'm going to call this one Amazon. I'm going to make it public so all teams can consume it. I'm going to create a default namespace in that pool called dev team, and the provisioner is Kubernetes. I go ahead and run that, and that'll register a pool that we can use for Amazon deployments. And then I'm going to give my dev team access to that pool by saying Shipper pool constraint set on the Amazon pool to the dev team. I'm going to go ahead and run that and append that constraint to the Amazon pool. Now next up, in order for Shipper in AKS to talk to Shipper in EKS, I need to go ahead and grab the token of that Shipper admin account that we've deployed in EKS. I'll do this by saying kubectl in the kube system namespace describe secret, and I'm basically retrieving the Shipper admin token from the Shipper admin service account that we've just created, and that'll spit out the token that I'm going to need. And in order to authenticate with Kubernetes on EKS using this token, I also need the CA certificate. So to do that, I'm going to say kubectl get secret, grab the secret, grep out the default token. Using awk, I'm going to grab the CA certificate and I'm going to decode it. So I go ahead and run that, and that'll give me the certificate that I'm going to need to connect Shipper on AKS with Shipper on EKS. So to connect my EKS cluster, I'm going to go ahead and sign into my Shipper dashboard, and I'm going to head over to clusters. I'm going to hit the plus sign to add a new cluster, and I'm going to call this cluster Amazon. I'm going to assign it to my dev team. I'm going to assign the pool, Amazon pool that we created earlier, and I'm going to need to define an address here. To get the address of the cluster on EKS, it's very simple. You head over to the AWS management console, go to Elastic Kubernetes service, go over to clusters, find the cluster you're looking for, and then copy the API server endpoint here. Go ahead and copy that, and all we have to do is paste that in the address bar over here. Then for the token value, I'm going to go ahead and grab the token from the terminal over here. I'm going to paste that in there, and I can leave the username and password blank since we're using a token. I can then go ahead and click next, and now we're going to need the CA certificate. So for that, I head back to my terminal, grab the CA certificate we printed out earlier, and I go ahead and paste that in there. I then click next, and I can leave all the stuff as default. So Shipper will go ahead and create a load balancer type ingress in EKS and expose a public IP for it for our applications that's running in EKS. So I go ahead and add that cluster, and it'll take a couple of minutes to provision. And after a few seconds, we can see it's been successful. We have our Amazon cluster connected to Shipper, and we also have our Shipper core, which is the Azure cluster. And if I head over to the dashboard, we can see we now have a multi-cloud environment running 50% of compute on Azure and 50% of compute on AWS. So now we have a multi-cloud environment running on Shipper, 50% on Azure, 50% on Amazon. So now that we have a multi-cloud Shipper platform running on Amazon as well as Microsoft Azure, let's take a look what the developer workflow looks like for developers to deploy apps to the cloud.
Got a whole lot of lean in my cup, double dutch, call it starch.
So as a developer, to deploy my Golang application to the cloud, all I have to do is say Shipper app create, give it a name, use the static argument to refer to a Docker container, specify a team, so I'm part of the dev team, and I deploy to the default pool, which is running on AKS. I go ahead and run that, it'll go ahead and register our application. I then say shipper app deploy, and I point to my Docker image, and I say I want to deploy this image to my Go Hello World application. So I go ahead and run that, and Shipper will do the magic. So now we can see Shipper has gone ahead and pulled my image, it's created a deployment in Kubernetes, it's gone ahead and rolled out the pods and set up the web routing. Now to deploy my Python application, it's just as simple. I say shipper app create, I give my Python application a name, I say static to refer to a Docker image, I'm part of the dev team, and this time I want to deploy to the Amazon pool. So I go ahead and run that, and Shipper will register my app on the Amazon pool. To deploy my application, it's simple. I say shipper app deploy, I pass in the name of the container and the application I want to deploy to. This time Shipper will contact our node in EKS running on Amazon, create a deployment, roll out a pod, set up the networking, and get us a URL for where we can access our application on. And that's quick and easy. It's gone ahead and pulled our image to Shipper, rolled out a deployment, created a container, set up the web routing, and our applications are ready in a multi-cloud environment. To access our application, I can say shipper app list, and we can see we have two applications running. The first one is running in AKS, and the second one is running on Amazon. Now for the Golang application on Azure, I might not have a DNS, so I can just set a host file to access it, and I can go over to the browser on that DNS name, and I can access my Go application running on Azure. For Amazon, I can go ahead and access this URL, since AWS will already create a DNS record for this guy on the load balancer IP. So if I take this URL and I go to the browser, we can see I can access my Python application on my Amazon environment. So that shows you how simple it is for developers to deploy applications to multi-cloud environments without any knowledge of Kubernetes. So the key takeaway here is to learn that Kubernetes is a platform for building platforms, and that Kubernetes is not always the end game. So in this video, you can get the feeling that Kubernetes becomes the kernel of our distributed system, and Shipper becomes the user interface. And this gives us a modern distributed system platform that has all the benefits of Kubernetes underneath, and it takes away all the complexities and burden of dealing with Kubernetes directly. So remember to check out shipper.io for more information on the platform, and hopefully you've learned something new today. Be sure to check out the link to the source code down below and take it for a spin, and remember to like and subscribe and hit the bell. You can also join the community server with the link down below, and if you want to support the channel even further, be sure to hit the join button down below and become a member. And as always, thanks for watching, and until next time, peace.